Hello, welcome to Physics Online with OKLinks. All right, today we have a very important question facing us under capacitor. From the diagram, the question says, find the equivalent capacitance in the figure below. Find the equivalent capacitance in the figure below. Of course, look at the figure they are talking about. If you look at the figure very well, you find out that there is a network of capacitors. All right, we have 2 microfarad capacitor, 3 microfarad capacitor, 2 microfarad capacitor, 4 microfarad capacitor, and then another 4 microfarad capacitor. This is a network. Then these 2 and 3 microfarad capacitors, they are arranged in series. Of course, you can see the network, just straight line, series connection. Then these 2 and 4 are arranged in parallel. Parallel in the sense that there is a junction here. We have one arm at the top, the other arm below. That makes it a parallel connection. So this junction here makes the end of the parallel connection. And then this other arrangement, that is this 4 microfarad capacitor, is a series connection. So we are going to solve it accordingly. There is a formula for finding the series connection and then a formula for finding the parallel connection. Now, we are going to split it into parts. The first 2 is series. The second 2 here are parallel. Then we have the other one, which is a series. So we are going to tackle the parallel connection first. And then when you have parallel connection for a capacitor, then what you do is just to add the 2 values directly for you to be able to get the value of the capacitance. Therefore, reducing this diagram, we're going to have the first one, which is 2 microfarad, joined with the second one, which is still 3 microfarad. That is, this one is for this, then this other one is for this. All right, then the parallel connection, that is 2 and 4 microfarad capacitors. I told you that when they are arranged in parallel, you just add them straight away. So 2 plus 4 here, we now have 6 microfarad. Okay? Then we now have this other one left. We now extend it again, and then we have 4 microfarad. We now extend the diagram. So this is now a linear connection or series connection of capacitors. We have 2, 3, 6, and 4. So what we are going to do now is to make use of the formula for calculating the series connection, the series arrangement of capacitors. And then the formula, since there are 4 capacitors arranged in series, that is 2, 3, 6, and 4, we're going to have that 1 over the total capacitance is equal to 1 over the first capacitance plus 1 over the second capacitance plus 1 over the third one plus 1 over the fourth one. Okay? So we now substitute accordingly. 1 over C is equal to 1 over, the first one here is 2. Then the second one here is 3. Then the third one is 6. Then the fourth one is 4. So all we need to do now is to do the mathematics remaining here. And then 1 over C is equal to, all we need to do is find the LCM of 2, 3, 6, and 4. The LCM, of course, is 12. Right? Then 2 goes into 12. We now have 6. 6 times 1 is 6, plus 3 goes into 12 is 4. 4 times 1 is 4, plus 6 divides 12, we have 2. 2 times 1 is 2, plus 4 divides 12 is 3. 3 times 1 is 3. So the next thing is to add the numerators. Okay, and then we are going to have 6 plus 4 plus 2 plus 3 gives us 15 all over 12, right? Okay, so what it means is that, okay, yes, we can still cancel out. Okay, what can cancel? Okay, 3 can cancel. 3 goes into here, we have 4. 3 goes into here, we have 5. Alright? Okay, let's go again. What it means is that 1 over c is equal to 5 over 4. Okay, so when you cross multiply and make c the subject of formula, you're going to have that c is equal to 4 over 5, or just 0.8 microfarad, and that is the final answer. So the equivalent, or yes, the equivalent capacitance of the figure is equivalent to what? 0.8 microfarad, or simply 4 over 5 microfarad. Okay, thank you very much, and bye-bye.